Hello everyone and welcome back again to my channel. Today I'm going to show you how to multiply and divide two complex numbers in polar form and also express them in the form of a plus bi or in rectangular form. Without further ado, let's dive right into it. The question reads, if z1 is equal to 6 open bracket cos 5 pi over 12 plus I sine 5 pi over 12 and z2 is equal to 3 open bracket cos pi over 4 plus I sine pi over 4. Find z1 times z2 and z1 over z2 in the form of a plus bi. So we are basically being asked to evaluate these two, multiply them and divide them and then express them in rectangular form. Well, here are some things you need to know. Every complex number has two parts. The real part, this is the real part, and then the imaginary part. Okay? Any part that carries I is classified as the imaginary part. And every part that does not carry an I, you can see there is no I here, and there is none here, no I here. So these are the real parts. This is the real part for the first one, and this is the real part for the second one. This is the imaginary part for the first one, and this is the imaginary part for the second one. So every complex number has a real part and an imaginary part. Even this one here, this is the real part, and this is the imaginary part. So wherever you see an I, it's simply the imaginary part. Now let's solve this very problem. So we say solution. First and foremost, we're going to write the formula for multiplying two complex numbers in polar form. The formula is z1 times z2 is equal to r1 r2 then multiplied by cos theta 1 plus theta 2 then plus I sine theta 1 plus theta 2. Okay, so this is the formula for multiplying two complex numbers in polar form. Okay, now the R is the modulus. Okay, you can see two moduli here. The two of them make up the moduli, but when you have only one, we call them modulus. This is the modulus. This is another modulus. The theta is called the argument. So the theta is called argument. So whenever they say find the argument is simply the theta. Either theta 1 or theta 2. They are called the argument. For example, if you look at here, you see that pi over 4, okay? Pi over 4 is the argument. 5 pi over 12 is also the argument. So these are the arguments for the real part. And for the imaginary part, 5 pi over 12 is the argument for the first part. And pi over 4 is the argument for the second imaginary part. All right. So now let's define what we have. Right here, we have our theta 1. Okay. So theta 1 simply means the argument for the first complex number. And we have it here to be, that is for the real part. Here, this is our theta 1. So it is 5 pi over 12. So we write 5 pi over 12. And then theta 2. Theta 2. Okay. So this is the argument for the other one, the real part. So we say pi over 4, pi over 4. And then for the imaginary part, I'm going to say for the imaginary part, our theta 1 for the imaginary part is also 5 pi over 12. And then for the other imaginary part, it's still pi over 4. You can see it here. So the imaginary part is pi over 4. and the imaginary part for the first one is also 5 pi over 12. So let's plug them in and start solving. Here we have z1 times z2 is equal to, so this is the modulus, okay? Now the number attached outside is the modulus. You can see right here, this is the modulus. This is our first r, and this is our second r, okay? So we multiply the two of them together, and this gives us, since we said r1 times r2, so we now have 6 times 3, and then we open our bracket. Right here, we're going to have cos, open bracket. Our theta 1 is 5 pi over 12. So we say 5 pi over 12, then plus pi over 4. You can close it. And then we say plus I sine. This is now the imaginary part, open bracket. Again, we have our theta 1 to be 5 pi over 12 plus pi over 4. Okay. Now let's go ahead and evaluate this. So 6 times 3 gives us an 18. Then we have the cosine. So here we are going to find a way to get the common denominator. The common denominator, since there are two fractions here, the common denominator between 12 and 4 is 12. So let's now simplify. 12 divided by 12 is 1. 1 times 5 pi is 5 pi. And then 12 divided by 4 is 3. 3 times pi is 3 pi. So we now have a common denominator. We can now add them. Then the next one, which is the imaginary part, is I sine. We have I sine, open bracket. Since they are the same, right? We just have to write them. They are just the same. You can see 5 pi over 12 plus pi over 4. And it's also the same thing here. So we just combine them since we've already gotten a common denominator. So 5 pi plus 3 pi all over 12. Okay. Now let's go ahead and add them together. Here we have 18, open bracket, cos 5 pi plus 3 pi would give us 8 pi over 12. And then plus I sine, open bracket, the same thing applies, 8 pi over 12. And then we can close the brackets. So when they say express it in the form of a plus bi, they're basically telling you or asking you to remove these arguments. Okay, remove these arguments. They don't want to see them again. And these trig functions. I'll show you how to do that. We're actually getting there. Now here, let's now go ahead and evaluate this. So we have 18. We now open our bracket. Please make sure that your calculator is in radians before you evaluate. Please make sure. So let's go ahead and do that. We can actually reduce this. So here 4 can go into 8. So 8 divided by 4 is a 2. And then this one here, 12 divided by 4 is a 3. Therefore, you now have 2 pi over 3, close the bracket, plus I sine, open bracket. The same thing also applies, 2 pi over 3. Okay, then let's go ahead and evaluate them right now. Please pardon me for this. Okay, correct. So let's go ahead and punch these values in our calculator. Please make sure your calculator is in radians. So here we have 2 pi over 3, or cos 2 pi over 3. Okay, cos 2 pi over 3, 2 pi over 3. So this is giving me negative half. So we have 18 multiplied by negative 1 over 2 plus, And here we have the next one, which is sine 2 pi over 3. So this is giving me root 3 over 2. So we have root 3 over 2, and then it's still being multiplied by I. Okay, so this one right here is the real part, while this is the imaginary part. So let's continue. We now have to distribute the 18 across. So 18 times negative 1 will give us negative 18 over 2. Then plus, right here we have 18 multiplied by root 3 will give us 18 root 3 over 2, and then you have an I. Okay, so when we simplify this, negative 18 divided by 2 is going to give us negative 9, and then we have plus 18 divided by 2 again will give us 9 root 3, and then you have your I. Okay, so this is the rectangular form of the first complex number that we evaluated. If you look closely here, you find out that here we have the real part. This right here is the real part, and here is the imaginary part. So this is just how it is. Okay, now we can go ahead and solve the other one. You can see that this is already in the form of a plus bi. So we see a plus bi. This is the real part, and this is the imaginary part. All right, so let's go ahead and solve the other one, which is the division. Okay, so here, remember, we have our given parameters already. So Z1 over Z2. The formula for dividing two complex numbers in polar form is giving us R1 over R2, then multiplied again by cos. Okay, then you open your bracket, theta 1 minus theta 2. For the multiplication, you use a plus. For the division, it's a minus. Then plus I sine, open bracket, theta 1 minus theta 2. Okay, then you close it. Having defined our given parameters, we know that our theta 1 for the real part, we got that to be 5 pi over 12, if I'm not mistaken. You can see it here. Here we have 5 pi over 12 for the real part. That's for the first complex number. And 5 pi over 4 again for the other one. And we can use these parameters to evaluate the Z1 over Z2. So for our other one, we had a 6, which was the first modulus, and then the R2 was a 3. So we can open our brackets, and we have cos. Our theta 1 was said to be 5 pi over 12, and this is minus theta 2 was pi over 4, and this was for the real part. For the imaginary part, we have I sine, open bracket, 5 pi over 12 minus pi over 4. Okay, so this is for the imaginary part. Let's now evaluate them. We just have to get a common denominator. 6 divided by 3 again would give us a 2. So here we have a 2, and then we open our bracket and get a common denominator. We have a cos. The common denominator again between these two is 12. We have a 12 here. So 12 divided by 12 is 1. 1 times 5 pi is 5 pi minus 12 divided by 4 is 3. 3 times pi is 3 pi. We close the bracket, and this is plus I sine, open bracket. Again, we write the same since they are just the same. So we say 12 5 pi minus 3 pi. Then we can close our brackets. Okay, Now we say Z1 over Z2 is equal to, we can now simplify. Here we have Z2, then multiply by cos. We open our bracket. Let's simplify this. So 5 pi minus 3 pi is 2 pi, and this is over 12. We can close it. We say plus I sine. Here we have the same thing to be 2 pi over 12. Now what do we do at this point? We can go ahead and simplify the fraction. So we say Z1 over Z2 is equal to 2, then open bracket cosine. Okay, so now 2 can go into itself. We have 1, so 12 divided by 2 gives us a 6. So we're left with pi over 6, then plus I sine, open bracket, pi over 6. Okay, now having reached this very point, we can now evaluate them to see what we shall obtain. Punching on my calculator, right here we have pi over 6. So we say cosine pi over 6, pi over 6. I'm getting root 3 over 2. So this gives me 2 multiplied by root 3 over 2. And then we have plus. So let's take the sine of pi over 6. Sine pi okay, pi over 6. I'm getting 1 over 2. So we say 1 over 2 and then multiply by I. You have to always include the I because it indicates you're dealing with the imaginary part. And then let's go ahead and simplify this. So when you multiply 2 times root 3 gives us 2 square root of 3 over 2. And then plus 2 times 2, or 2 times 1 gives you a 2 over 2i. Okay? Now when you simplify this 2 and this one, they cancel out. So you're left with root 3 plus 2 divided by 2, they cancel out, and that's 1. So you cannot say 1i, you simply say I. Okay? So we now have seen that Z1 over Z2 is equal to root 3 plus I. And this is the form of A plus BI because this is our real part and this is our imaginary part. Thank you for watching this video. I believe it has helped you in some way. Well, I'm going to be posting more videos on complex numbers to help you understand this concept better. See you in the next video and bye.